Today we're going to be looking at a tube tester that I purchased on eBay. It's a TC-109, dates back to probably the late 50s, early 60s. I'm planning on working on some tube radios, repairing them, getting them back into shape, and I'm going to need a tube tester. That's the purchase that I made on eBay. Got a good price on it. However, it is old, and anything that old is going to need a lot of, or at least some work on it. I'm going to take a look at it, probably need to replace some of the wax capacitors that are in it, and also calibrate the unit. So that's what this video series will be about. I hope you stay tuned. Well, here we are with the Sencore Mighty Mite tube tester, TC-109. I looked on the internet and tried to find a history of Sencore. About the only thing I could find was that they were incorporated in 1951, and this was one of their first actual tube testers. Before this, they had a little tube checker that was a little bigger than a novel that would test the filaments. This was the beginning of their Mighty Mite tube series, tube checker series. And this differs from some of like the Hitchcock testers in that it does not test the actual conductivity of the tube. It tests the emission of the cathode. And for most purposes, for just checking a tube if it's good or bad, this will do that. It'll check the filament, it'll check the emissions, and it'll also check the, and if you have any shorts, which actually what I've read online, the Sencore TC-109 tube checker was very good at detecting grid leakage. So let's take a look at this. It's in pretty good shape. I noticed that the case doesn't have much rust on it. That's a good sign. It probably was kept in a fairly dry environment. The meter cover is a little scuffed up, but we might be able to buff that out. All of the knobs work. Everything turns. The tubes, sockets, some of them are a little worn, but that's to be expected with something this old, particularly if it was used a lot in a shop or doing service calls. Inside we have our good old line cord. This is something we're going to change. As you can see, it has the just regular two prongs on it, and we'd like to change that to a polarized plug. We'll get into that more once we take it apart. I did notice that someone had disconnected the cathode ray tube checker, which doesn't bother me because I probably won't be checking any cathode ray tubes anytime soon. And it also came with a adapter to be able to adapt for testing smaller radio tubes, miniature type tubes. The one side is just a little bit smaller than this side where the pins are. It didn't come with a service manual, but I found one easy enough on the internet. And within the service manual, there's a parts list, which will come in handy. And also a schematic, which will come in handy. I've already gone through and marked in yellow where the capacitors are located, and in red where some of the critical resistors are that do the measuring. My plan is once we get this apart, I'm going to check the tolerances on all the resistors and probably replace at least the electrolytic computer that's here, and we'll check the tolerances on the others, and we might also replace those. So let's take a look inside, take it apart, see what the condition is. Remove these 4 screws. We'll lift this out. I notice also this is the grid, or the cap for the tubes. Normally grids, sometimes plates. And the lead's broken off, but that's going to be easy enough to fix because it looks like this just pushes out. In fact, it pulls out. I'll just solder a new wire on there. Might replace the wire also. It's fairly heavy. I noticed that when I had to pay for the shipping. Shipping was about a quarter of what I actually paid for the tube tester. Another good sign. The inside there looks nice and clean. No rust to speak of. The only wear that's really on it is on the handle here where it says Sencore. You can tell that it probably got rubbed against something a lot. Maybe a tube caddy, toolbox. But even the bottom is in pretty good shape. I was going to paint the box, but I don't see any reason to do that now. It's in pretty good shape. Okay, let's take the back cover off. This is made, it's clever of Sencore, this was made so that you could cut a hole in your workbench and just place this down inside of it, run the electric down under your workbench, and it'll be mounted in your workbench. Also, some shops I've read would mount this out in a public area and would encourage walk-ins to come in and test the tubes. And of course, hopefully if the tube was bad, they'd make a little money on selling a tube. In fact, I remember when I was probably a teenager, 15, 16 years old, taking tubes down to the local drugstore and having them checked, primarily for our television. And I fixed our television many times by just replacing the vacuum tube. That was bad, and usually the filaments would burn out on them. The back comes off, and it looks pretty clean in here. We have one tube that does the testing. It's a 6C4 tube amplifier. One of the things you want to look for when you open one of these up is to make sure that no one has been in here and tried to rewire things, change things radically, particularly someone who didn't know what they were doing. Now I see up here there's some insulation cut. That's where the cathode ray tube socket goes, and that's nice because they left a little bit of the wire there so I can tell how to hook it up without having to go back and look at the schematic. Something else that you want to look for when you get a tube tester of this nature is to see if anyone has just showered these switches with tuner cleaner or some type of cleaning agent. And it looks like these are in good shape, and that's good, because if you spray these with a contact cleaner, it's very difficult to get all of that contact cleaner residue off. And that comes into play when you are using the tube checker to check the grid leakage, because it'll throw it off. This is somewhere in the area, I think it's 100 megs, or 100,000 megs even. I'm not sure, I'll have to look on that. So a little bit of residue in between the contacts and the sockets or on the switches will throw that off, and you'll get bad readings. Now looking in here once again, get the glare away. I see several wax paper capacitors. There's one here, there's one down in here. It's not too bad. That's the only two wax capacitors that I see in there. So those will definitely need to be replaced. This looks like an electrolytic actually. This is the wax paper capacitor. Over here is something you don't see anymore. This is a selenium rectifier. Almost everything now is silicon diodes. So there we have it for now. I think I'll stop the camera right now, and I'm going to check on these capacitors and get back to you. I want to completely remove the capacitor. I know sometimes people will cut the leads off right here and just twist the wire around, and I just, maybe I'm a little bit of OCD, but I want to take it out, do it right, empty out the connecting terminal, and solder the capacitor in there so it looks good. Okay, we're back. I have the two capacitors replaced. The electrolytic and that paper wax capacitor is installed now. Now I'm working on the power to the unit. As I said, I'm going to replace the old cord that just had 2 prongs with the 3-prong grounded wire, which has the ground, the neutral, and the hot wire. I put a grommet on it. The old grommet was worn, broken, so we have a new grommet. Put a tie wrap on there to hold it, strip the wires back. It enters in right up here. I'll put the little green dot, so the wiring will come in and go back through there. Also, the unit did not have a fuse in it. Back in the early 60s, they didn't figure that was important. But if the transformer over here would short out, then that's going to put a heavy load on. You could burn up the transformer. Other things can happen if you have a direct short. Something breaks, a wire moves. So I'm going to put a wired in fuse right here by the rectifier. I would like to have used a fuse holder such as this, but I just could not find any place to mount it. Preferably it should be down in here. There's no place to mount it. It would entail having to drill a hole through the board, and because there's writing on the board here, I didn't want to do that. I thought about putting it up here on the meter right here, but it's awful close to the other windings, and I'm not sure how much the 110 volts would affect when testing a tube. So that's when I decided to go ahead and just use a 2 amp wired fuse, and that should do the trick. So what's next is I have to wire the fuse in, wire up the power cord, and then we'll be back. I'm always curious to see how the old capacitors, like this old electrolytic from that long ago, how well they're standing up. This is supposed to be a 20 microfarad capacitor, and as you can see it's measuring at 24, and we'll check the dielectric, and it's not really too bad either, 0.018. The other one was a 0.1. We'll check it. It's right on the nose, 0.10, and the dielectric on it is not too bad either, 0.018, 20, or somewhere around in there. So probably both those capacitors would have worked, but usually it's a good idea to replace capacitors that old, particularly the wax paper ones. It will ground it and protect the user. I'm going to use my big soldering iron because that lug is connected to the chassis there. It's going to take a little bit of heating up. That's done. And looking at our wiring, this would be our hot wire. So it will go here to where the fuse is. I think I'll stick with my large soldering iron, soldering gun. And while we're in here, we'll go ahead and do this side of the fuse. Let that cool a little. Then the white wire goes over here, down in this tight little area. I have to take the old one off. That came off pretty easy. Sometimes they are wrapped around there pretty good and becomes frustrating. I'm also wiring this up so the neutral in the schematic, it shows this wire coming in, this wire coming in here from the neutral and going up to the off and on switch, which is also going into the ground. It's not connected to the chassis, but just to be safe, that's going to be the place where we hook up the neutral wire. So it's already onto the chassis ground, and we have the chassis earth grounded, so that should make the unit safer and up to today's codes that they didn't have back then. I'm going to tint this wire. That'll allow me to wrap it around that lug a little easier. Wire's just a little bit bigger than the hole in the lug. There we go. Put a little solder on there and we'll be done with that. So now our wire is in there. This is where it will come in, about here. There's plenty of room in here. The depth of this item, as you can see, is pretty deep. So there's plenty of room for our fuse so it won't short out with anything. So that's it for the power cord and the fuse. We got the capacitors in. Next thing I'm going to do is check the resistors that are over here. These are all composite resistors. I'm going to check them and possibly replace them with 1% resistors. Ended up replacing all the resistors here on the load switch. Most of them were within the 20% range. One of them, at least the high-end ones here, were a little off, and the 680 ohm was off. It was 723. Still within the tolerance, but it was probably one of the worst ones as far as out of tolerance. So since I had to take two of them off and the third one off, I decided to go ahead and just replace all of them. These are two 220 ohm resistors, and the 150 ohms are pretty close. They're within a few ohms. One is within 2 ohms, one is within 7 ohms. So, and a 20% tolerance on those is 30 ohms difference, high or low. So I decided to keep them the same. So those are done. I'm going to go ahead and check some of the other resistors that I feel are in some critical areas and make sure that they're correct. And hopefully soon here we'll be able to put the tube in and fire it up and see how it works. I ended up deciding to hook up the cathode ray tube wiring since I was in here and working on it. So I ended up soldering the wires back on to the appropriate points, and I have the cathode ray tube. I also put some shrink tubing on it instead of that nasty tape that was all gooey, so it's a lot nicer, and have the clip wire back in. So it looks like we're ready to actually assemble the unit and turn it on. I have a new 6L4. This is the same tube that's in it. I got the chart here, and the chart says that it's 6 volts. Set this on E. This should be set on 1 for the setup, and letter F. And this says that it should go in socket 4, which is here, but obviously this will not fit in socket 4. It sits in socket 3. So I don't know if that's a typo or what. I'll have to check that. We turn it over to calibrate. It's warming up. Tube warms up. So, okay, let's go through the short test. Put it in short. Goes over to good. Rotate this through. If the light comes on and it stays on. That's an indicator. All I do is see it blink there, but it's okay. So that stays in F. Let's go to the grid leakage. It looks good. It's over in the good part. Let's go to emissions testing. Okay. The emissions testing shows that it's bad. Now I don't know if that's because it's in the wrong socket according to what they say here, which is socket 4, which it won't fit in 4. It obviously fits in 3. So I guess we have a little more work to do here and troubleshoot. Oh, welcome back. I found out why we were having a problem checking a tube, and I was looking at the wrong chart. Apparently there is a universal tube setup chart for all tubes and all Sencore testers except the TC-109. So it took a little searching around on the internet, and then I found the chart for that. Before we check a tube though, I want to go through the procedure for aligning it, which is it's a really simple procedure. The first thing you do is you do the calibration, and then you move back here to the back, and there's 2 control pots in here. The one control pot is the same as on the front for setting or calibrating it to 0, and then this pot down here you calibrate for full scale when the fret function is in short. So let's try that. First we make sure it's in the calibration mode, and then we can use the calibration. Easier to use it from the front, and you put it on where it says calibrate. Line it up. Then you put the switch in short test. Then on the pot in the back, the one next to the tube, you adjust it so that it's on the 0, not on the end of the scale, not here, but right here where it says 0. There. Now you go back to calibrate and make sure this is still on calibrate. As you can see, it changed a little bit. Put it right there on the end. Put it in the shorts position again, and it's pretty close to 0 there, and the calibrate there. That's all you have to do to calibrate the Sencore TC-109, which is a lot easier than some other testers out there. Now let's test a tube. We're going to look it up here in the chart. So it said this is a, that's not the right one. Let's find it here. There it is. Right there, a 6C4. So we can see that the A switch is 6, that's the filament, 6 volts. The B switch is E. The C switch is 1, and the D is D, and it goes in socket 3, which if you remember earlier, that I was wondering about that because it said it should go in socket 4, but obviously socket 4 was larger than socket 3, which is where the tube fit. So that should have been a warning sign to me that something wasn't right. Okay, the first one is on, should be on 6. Then we go on E. This should be on 1. And then D. It's already on D. Let's put it into socket 3. First thing we do, we check for shorts. We go over here, see if the little short light flashes. on and stays on as we rotate through the load. Okay, it looks good. Grid leakage, just a tad. The needle moved, but not much. Then emissions. Now the tube tests good. Goes into the good area. This is actually the tube that was originally in the tube tester. I put the brand new tube in, thinking that might have been a problem. So as you can see, it seems to be working. What's left to do is to put it back in the case. I want to clean up this the cover a little bit. There's some dirt on here I think that can come off easily just by a little wiping, and we might work on this meter cover and see if we can get it a little of the smudges out of it. I think what they've done is they took and put the this through this inside, and you can see where the wires were rubbing on the plastic, so we should be able to get that out with a little rubbing compound. When testing some tubes and working with a little bit, I did find a tube that has a bad grid leakage. It's a 12 SL7 that I have in there, and it's got 3 parts, and I found that on the 3rd part, if we go through and look at the grid leakage, it goes over to bad right here. Emissions, it shows still good, so that could cause problems if it were used in a radio. I got the plate cleaned up, or the meter face plate cleaned up pretty good. Hardly tell that there's some scratches in it, some of the real deeper ones down here and here, but looks really good. The products that I used, this is the first time I've used them, even though I've seen them advertised by different restorers, radio restore people, TV stores, is this Novus 1, 2, and 3. The number 1, actually number 3, you start with 3 for heavy scratch removal, and it did a pretty good job of getting rid of them. Then the finer scratch removal, was surprised, it kind of had a little glaze on it. Then you put the plastic cleaner and shine on and buff it up, and I'm very impressed with it. So I'm glad that I bought it. I bought it on eBay. It wasn't that expensive. I think for all 3 bottles, $10 or less, plus a little shipping. Well, the unit does work okay. I have some tubes here. I have a a 12 SK7, and it's already set up for that. If I put it in, I can go through the shorts test. I already did that. Grid leak looks good, and the emissions, once the tube warms up, you can see the meter move up, and it's in the good area. It goes up a little higher if you leave the bulb or leave the tube in, so the filament warms up. So I think it's a pretty successful restore project. We did restore or replace, if I can find them here. As you saw, the capacitors were within specs, but they're pretty old, particularly this electrolytic. It was just a matter of time it would probably go bad. And most of the resistors were within the 20% range. I replaced them with 1% resistors because I already had them on hand. That might improve the accuracy just a little bit, though this is by no means a fine tube tester to check transconductance. So that pretty much concludes everything now. The Sencore Mighty Mite TC-109. This is the first one in their line of Mighty Mites, and they went on to produce 5 or 6, I believe. Basically the testers are the same. They just allowed you to test more tubes. They had more sockets, and of course they updated the charts. And as I said, remember, if you get a hold of one of these, you have to have the chart that is actually for, it says just on it, operating instructions for the Mighty Mite tube tester TC-109. The universal tube charts are inaccurate because apparently they decided to change the socket numbering. And there might be some other in the settings, the setups. Well, thank you. I hope you enjoyed this. Hopefully I'll have some more coming when I restore one or two of the radios that I already have. And thank you for watching. Give a thumbs up there for the YouTube video, and I really would appreciate it. Thank you.